In the summer of 1933, a rancher in South Texas walked out to check on a calf that had been born 2 days earlier. The calf was still standing, but something was wrong with the navel, and when the rancher leaned in close, he saw movement under the skin. Not one worm, hundreds of them, packed shoulder to shoulder, chewing their way inward while the animal was still alive. That calf was dead within a week. So were 9 others on the same property, and across the American South, ranchers were losing so many animals to this one insect that entire counties were quietly going broke. For decades, nobody could stop it. You couldn't spray it away. You couldn't fence it out. You couldn't breed animals tough enough to survive it. The losses ran into the hundreds of millions of dollars every single year, and the standard answer from every expert who looked at the problem was the same: learn to live with it. Then a government scientist who spent most of his career being ignored proposed something that sounded, on its face, completely insane. He said the way to kill every last one of these flies was not to kill them at all. It was to raise billions of them in a factory, ruin them on purpose, and then drop them out of airplanes over the exact places where they were breeding. His own colleagues thought he had lost it. One of them reportedly told him the idea was a waste of paper. And yet, today, that method is the reason a fly that once ate its way through the entire southern United States has been pushed out of North America completely. It is one of the cheapest, quietest, most effective wins in the history of American agriculture, and almost nobody has heard of it. If you like stories about the strange, low-cost solutions that quietly changed how ordinary people live and eat, hit subscribe. This channel breaks down the smart, cheap fixes that made modern life affordable, and this one is easily the strangest in the bunch. Now, let me show you exactly how it worked, and why nobody believed it would. The insect at the center of this story has a name that sounds made up: the New World screwworm, Cochleomia hominivirax, if you want the Latin. And that second word translates roughly to devourer of man, which tells you most of what you need to know about how early naturalists felt about it. To look at, it is unremarkable. A metallic blue-green fly, a little bigger than a housefly, with orange eyes and 3 dark stripes running down its back. If one landed on your picnic table, you would wave it off without a second thought. There is nothing about it that says catastrophe. The problem is what it does with a wound. Most flies that lay eggs in animals are scavengers. They want tissue that is already dead. The screwworm is different, and that difference is the whole reason this story exists. A female screwworm fly finds a living animal with any opening in the skin, a tick bite, a cut on a fence wire, a branding burn, the soft navel of a newborn calf. She lays a batch of 200 to 300 eggs right at the edge of that wound. Within 24 hours, those eggs hatch. And what comes out is not a scavenger. The larvae have a set of hooks on their mouths and a body ringed with small spines that let them screw themselves down into living flesh. That is where the name comes from. They burrow head first, tail up, breathing through the opening they came in by, and they eat living tissue as they go. A wound the size of a fingernail can turn into a hole the size of a fist in less than a week. And here is the part that turned this from an animal welfare problem into an economic disaster. The feeding wound gives off a smell that other female screwworms can pick up from a long way off. So the first infestation attracts a second, and the second attracts a third, and an animal that started with a minor scratch ends up carrying thousands of larvae in multiple sites on its body. Untreated, a full-grown steer could go from healthy to dead in 10 days, and there was very little a rancher could do once it reached that stage. Ranchers described walking their pastures and hearing the animals before they saw them, because a badly infested cow makes a sound that people who worked in that era never really got over. It did not stop at livestock. Wild deer populations collapsed across large stretches of the infested regions. Dogs, goats, sheep, horses, pigs, and yes, people. The medical literature from the first half of the 20th century contains case reports that are genuinely difficult to read, most of them involving children, elderly patients, and anyone with an untreated sore who slept outdoors in a screwworm zone. It was rare in humans, but it was not theoretical. Now, ranchers are practical people. and they did not sit around waiting for the government to fix this. For roughly 50 years, they threw everything they had at the problem. The first line of defense was inspection. On a well-run operation, every animal got checked by hand every few days during fly season. If you found a wound with larvae in it, you dug them out and packed the hole with whatever was on hand: pine tar, turpentine, chloroform mixtures. Later on, benzol and diphenylamine smears that came in tins from the feed store. This worked in the sense that it saved individual animals. It did nothing at all to the fly population. You could clean up every cow on your ranch, and your neighbor's untreated herd would reseed the whole valley in a month. The second approach was timing. Ranchers shifted their entire calendar around the fly. Calving got moved to the coldest part of the year, because screwworms cannot survive a hard freeze. Branding, castration, dehorning, anything that broke the skin got pushed into winter months. Whole regional economies bent themselves around the breeding cycle of an insect, which is one of those details that sounds small until you think about what it actually means. Millions of acres of American agriculture running on a schedule dictated by a fly. The third approach was chemistry, and this is where the story usually goes wrong in other countries. After the Second World War, cheap organochlorine and organophosphate insecticides arrived, and the instinct was to blanket everything. Dips, sprays, powders. It knocked populations down temporarily in small areas, but the flies could travel more than 100 miles. They bred continuously in warm zones, and the survivors of each spraying passed on whatever tolerance they had. Within a few generations, you were spraying more product for less effect at higher cost, with residue problems in the meat supply. By the early 1950s, the accounting was brutal. Direct losses to the American livestock industry ran somewhere between $200 and $400 million a year in the money of that time. Adjust that forward, and you are looking at billions. Every dollar of it landed on small operations hardest, because a rancher with 40 head could not absorb the loss of 6 calves the way a corporate operation could. Everyone accepted this as a permanent cost of doing business. It was a line item, like feed and fencing. That is the mental state you have to understand to appreciate what happened next. Edward Fred Knipling was not an obvious candidate to solve one of agriculture's oldest problems. He grew up on a farm in Port Lavaca, Texas, one of 9 children in a German-speaking household, and he worked his way through Texas A&M with money he earned trapping and selling animal pelts. He joined the U.S. Department of Agriculture in the early 1930s as an entomologist, which at the time meant he was mostly expected to catalog insects and recommend which poison to use on them. Knipling did not think like that. Starting in the late 1930s, while stationed at a screwworm research lab in Menard, Texas, he became fixated on a detail in the fly's biology that everybody else had written down and moved past. The female screwworm fly mates once, just once, in her entire life. She stores the sperm from that single encounter and uses it to fertilize every batch of eggs she will ever lay. Read that again, because the entire story turns on it. If a female mates with a male that cannot give her viable sperm, she does not go looking for another male. She spends the rest of her life laying eggs that will never hatch. She is, functionally, removed from the population, without ever being killed. So, Knipling asked a question that nobody in his field was asking. Instead of trying to kill the flies, what if you flooded the environment with so many sterile males that the average female had almost no chance of finding a fertile one? The math on this is what makes it beautiful, and it is worth walking through slowly, because it is the opposite of how pest control usually works. Say you have a wild population of 1 million flies, half of them female. If you spray and kill 90%, you have congratulated yourself on a massive victory, and you still have 50,000 fertile females out there, each capable of laying over 1,000 eggs across her life. The population rebounds in one season. Now do it Knipling's way. Release 2 million sterile males into that same environment. Now the wild females are choosing from a pool where sterile males outnumber fertile ones 4 to 1. Roughly 80% of matings produce nothing. The next generation is a fraction of the size it was. Here is the part that makes it a weapon rather than a treatment. You release the same number of sterile males again, but now the wild population is much smaller, so the ratio of sterile to fertile males is not 4-to-1. It is 20-to-1. The third release, it might be 200-to-1. Each round, the odds get worse for the wild flies, not better. Spraying gets less effective as you go, because you kill the susceptible ones and breed the resistant ones. This gets more effective as you go. It accelerates towards zero. That is a completely different shape of problem, and it means that with enough patience and enough factory capacity, total elimination is not just possible, it is the natural end point. Knipling wrote this up and circulated it. And the response was, to put it kindly, cool. It is easy, looking back, to treat this as an obvious idea that a genius spotted and everyone applauded. That is not what happened. The first serious problem was that nobody knew how to sterilize an insect without wrecking it. A sterile male is useless if he is too weak to fly, too sluggish to compete, or too damaged to interest a female. He has to be a completely convincing suitor who happens to be firing blanks. In 1938, there was no reliable way to do that. The second problem was scale. Knipling was proposing to build factories that would produce flies by the tens of millions per week, feed them, sterilize them, package them, and distribute them by air across territory the size of a European country. In the middle of the Great Depression, walking into a federal budget meeting with that request did not go well. The third problem was cultural. Entomology in that era was a discipline built around killing things. Knipling was proposing to breed the pest deliberately in enormous numbers and then set it free. To a lot of his colleagues, that was not clever. It was reckless. What if the sterilization failed on a batch? What if you accidentally seeded a new outbreak in a clean county? So the idea sat. Knipling kept working, kept refining the math, and kept talking to one man who took it seriously, a fellow USDA researcher named Raymond Bushland. Bushland was the hands on half of the partnership, the one who would have to make the biology actually cooperate. The breakthrough came from somewhere nobody expected. In 1950, Knipling read about work being done on fruit flies, showing that X-rays could sterilize insects. That was the missing piece. Radiation damages the chromosomes in developing sperm without necessarily destroying the insect's ability to fly, feed, or mate. Bushland got hold of a surplus X-ray machine from an army hospital in San Antonio and started irradiating screwworm pupae. The dosing was delicate work. Too little radiation and some males stayed fertile, which would ruin everything. Too much and you got males that could barely stand up, let alone compete for a mate in open country. He worked the range down until he found the window where the insects came out sterile but still behaved like normal flies. They had the mechanism. Now they needed to prove it in the real world, and for that, they needed somewhere isolated. The first real test was not on the mainland. It was on Curaçao, a Dutch island off the coast of Venezuela, about 170 square miles of scrubland and goats. Islands are perfect for this kind of experiment because reinfestation from the outside is nearly impossible once you have cleared the ground. If the population goes to zero, you know it was you. The team started releasing sterile males by air in August 1954, at a rate of about 400 flies per square mile per week. They monitored the results by putting out wounded test animals and counting how many egg masses appeared, and then checking how many of those egg masses actually hatched. The first week, the hatch rate was normal. Almost everything the wild females laid was viable. By the second month, the numbers were moving. The proportion of sterile egg masses climbed past 50%, then past 80%. The wild females were still laying, still doing everything right, but the eggs were dead on the ground. By January 1955, 5 months after the first release, the researchers could not find a single screwworm on the island. Not a larva, not an egg mass, not an adult. They kept looking for months afterward because nobody quite believed it. The population was gone. Not reduced. Gone. That result changed the argument overnight. It was no longer a theory on paper from a man in Texas. It was a finished job on a real island with real livestock, and it had cost a fraction of what a chemical campaign would have run. Florida gave them their opening. In 1933, a shipment of infested cattle had carried the screwworm east from Texas, and by the 1950s, the fly was established across the southeast, costing Florida ranchers around $20 million a year. Florida is not an island, but it is close enough. It is a peninsula with a narrow neck at the top, which meant that if you cleared the state, you only had to defend a relatively short line to keep it clear. The operation launched in 1957, and it was, by any measure of the era, a strange industrial undertaking. The Agriculture Department converted an aircraft hangar at Sebring into what was essentially a fly factory. At full production, it turned out around 50 million sterile flies every week. Consider what that requires. You have to breed the flies, which means maintaining a colony of egg-laying females on a diet that keeps them producing. You have to feed the larvae on a growth medium, and in the early years, that medium was ground meat and blood from slaughterhouses, mixed in industrial vats. You have to time the whole thing so that the pupae reach the exact right age for irradiation. You have to run them past the radiation source at the correct dose. Then you have to chill them, package them into cardboard boxes with paper honeycomb inserts so they do not crush each other, load them onto aircraft, and drop them over a moving grid across an entire state. The drops themselves were done from low-flying planes running parallel lines, releasing boxes that opened in the air. Pilots flew the same patterns week after week, a slow grid over swamp and pasture and citrus grove, seeding the landscape with insects that could not reproduce. It worked, and it worked faster than anyone in the department had projected. By 1959, roughly 18 months into the campaign, the screwworm was declared eliminated from the southeastern United States. The estimated program cost was around $10 million. The annual losses it stopped were around $20 million in Florida alone. The thing paid for itself before the paperwork was finished. Florida was the easy version. The Southwest was going to be different, and everyone knew it. Texas alone is bigger than France. New Mexico, Arizona, and California added enormous amounts of additional territory, most of it hot year-round, which meant the flies never got a winter die-off to knock them back. And the southern edge of that territory was an international border that flies do not recognize. The Southwest campaign started in 1962, and the production facility this time was at Mission, Texas. At peak, it was producing well over 150 million sterile flies per week. Within 4 years, in 1966, the United States declared the screwworm eliminated from the country. It was the first time a major insect pest had ever been eradicated from a nation of that size, and the technique behind it was less than 30 years old. Because Mexico was still infested, and infested livestock crossed the border constantly through legal trade, informal movement, and wildlife that simply walked. Every time a pregnant female made it north, she could seed a new focus. There were serious outbreaks through the 1970s, and the worst of them, in 1972, produced around 90,000 confirmed cases in the United States. Ranchers in the border counties were furious, and they had every right to be. They had been told the problem was solved. What they were actually looking at was a defended line rather than a finished war. And defending a line costs money forever. The response was the only one that made sense. If you cannot hold the border, move the border. In 1972, the United States and Mexico signed a joint agreement to eliminate the screwworm from Mexico entirely, and to do it as a shared program with shared costs. A new production plant was built at Tuxtla Gutierrez in Chiapas, in southern Mexico, and it eventually reached a capacity of around 500 million sterile flies per week. That plant was, for years, the biggest insect factory ever constructed. The strategy was not to clear all of Mexico at once. It was to sweep like mowing a lawn in strips, clear the northern states, then hold that line while clearing the next band south, then the next. Each cleared zone became the buffer, protecting everything behind it, and the barrier that had to be permanently maintained got shorter with every step, because Mexico narrows as you go south. Mexico was declared free of screwworm in 1991, nearly 20 years after the agreement was signed. Then the sweep kept going, country by country, without pause. Guatemala, Belize, El Salvador, Honduras, Nicaragua, Costa Rica, Each country joined the program, and each one took years of releases, surveillance, and quarantine work. Panama was declared free in 2006, and that was the strategic prize, because Panama is where the continent gets thin. The permanent barrier now sits at the Darien Gap, the roadless stretch of jungle between Panama and Colombia. It is roughly 160 kilometers wide. That is the entire front line. Every week, sterile flies are still released along it, holding back a pest that once ranged from Argentina to the Carolinas. Think about the shape of that achievement. A continent-wide problem was reduced, over 50 years, to a maintenance job on a strip of jungle you could drive across in an afternoon if there were a road. Now here is where this connects to your grocery bill, because that is the part that never gets told properly. The United States Department of Agriculture estimates that screwworm eradication saves American livestock producers well over $1 billion every year. Mexico's savings are in the same range. Central America adds hundreds of millions more. Against that, the total cost of the program across its entire history, decades of factories and aircraft and inspectors, is a small fraction of 1 year's benefit. That money does not just sit in ranchers' pockets. It shows up as cheaper beef, cheaper dairy, cheaper leather, and cheaper meat in every country that participated. When you remove a permanent tax on production, the price of the finished product falls. But the effect on small operations was bigger than the effect on big ones, and that is the part I find genuinely interesting. A large ranch could afford daily inspection crews, chemical dips, and the loss of a percentage of its calves. A family with 30 head could not. In screwworm country, small producers were the ones going under, because they had no margin to absorb a bad season. Remove the fly and you remove the thing that was quietly killing the small operator. Subsistence farmers in Central America who kept 2 or 3 animals as their entire capital reserve stopped losing those animals to a wound that got infected. In rural Guatemala and Honduras, the arrival of the program meant that a goat with a cut leg was no longer a household financial emergency. The wildlife effect was just as large and got even less attention. White-tailed deer populations in Texas were suppressed for decades by screwworm, with fawn survival taking heavy losses every year. After eradication, deer numbers climbed sharply. Endangered species benefited too. The key deer of Florida and the Florida panther both had populations knocked down by screwworm infestation before the program cleared it out. And there is a human medical dimension people forget. Screwworm myiasis in humans was never common, but it happened. And it happened overwhelmingly to poor people sleeping outdoors, to the elderly, and to children with untreated wounds. Those cases simply stopped occurring across an entire continent. I am not going to pretend this is a clean story with no cost. You are, at industrial scale, deliberately breeding hundreds of millions of an animal per week in order to destroy its species across a landmass. Whatever you think about insect sentience, that is a serious thing to do, and it was done with almost no public debate. There are ecological questions too. The screwworm was a native species across most of its range. It had been part of those ecosystems for a very long time, applying pressure on wound survival in wild animals. Removing it changed deer densities, which changes browsing pressure, which changes forest composition. Those effects are real, and they were not modeled in advance, because nobody was doing that kind of modeling in 1957. There is also the fragility of the whole arrangement. This is not a permanent victory, it is a permanent expense. The Darien barrier only holds while somebody funds the plants and flies the planes. Stop for a few years, and that fly walks north again. Which is not a hypothetical. In 2016, an outbreak appeared in the Florida Keys and hit the endangered key deer hard, killing a significant share of the herd before an emergency sterile release program brought it under control. And in the 2020s, the barrier at Panama was breached, with the fly moving back up through Central America and reaching Mexico. The response has been to build new production capacity and push the line south again, which is exactly what the program was designed to do. But it is a reminder that the fly is not gone. It is held back. The sterile insect technique did not stop with screwworm. It is the shape of the thinking. Everyone working on screwworm for 50 years was trying to answer the question of how to kill more flies faster. They got better at it every year, and they never got anywhere because the question was wrong. The population kept regenerating from the survivors. It is usually something that looks sideways or slightly ridiculous right up until the moment it works. A man in Texas figured out that the way to erase billions of flesh-eating flies was to build a factory that made more of them. His colleagues thought he was wasting everyone's time. He turned out to be right. And the beef sitting in your refrigerator right now is cheaper because of it. If this is the kind of story you want more of, subscribe. Next week, I am breaking down another low-cost fix that changed everyday life more than anything in the news cycle did. The kind of thing that never gets a headline and never stops paying off. I will see you in the next one.